Alright, so this is our final lesson in our quadrilaterals module for now, and we're going to be talking about the application of quadrilaterals. This is what your exit ticket is going to look like. You have to do 3 pieces, so go ahead and read through this and see what you know and what you don't know. Just a couple of quick reminders that will be useful for our lesson today. The perimeter of any figure is found by adding up the sides. To find the length of each side, we use the Pythagorean theorem. And then also talking about our area formulas. So base times height and 1/2 base times height. But also keep in mind that in order to use these 2 formulas, I have to have a right angle. Alright, so in this first example, the city park is located at -3, -1, -2, -3, -4, -4, and -5, 2. How much fencing will the city need to enclose the park? Alright, so I see that I have coordinates, so it's going to be a lot easier if I put them on a grid. So if a grid paper isn't given to me, like on an exam, then I'm going to need to go and get some grid paper or make my grid paper. So I'm going to go ahead and get a piece of graph paper. And I'm going to graph my points. So -3, -1, and -2, -3, and -4, -4, and -5, -2. Alright, so this is the park. And I need to know how much fencing will the city need to enclose the park. Okay, so when I think about fencing, if I roll out some fencing, it's going to be linear. So if it's asking me how much fencing, it's asking for this linear measurement plus this linear measurement plus this plus this. So I'm looking for the length of each side, and I'm wanting to find the one-dimensional. So the perimeter is essentially what we're talking about. So to find the length of each side, I'm going to have to use the Pythagorean theorem. So I'm going to go ahead and label these just so I can keep track of what I've done and what I haven't done. So AB is going to be the square root of 1 squared plus 2 squared. Which is 2.24. And then BC is also 1 squared plus 2 squared, which just looks a little bit like a square. So I'm going to guess all sides are equal, but I can't assume anything. So C to D is 1 squared plus 2 squared. And D back to A. Alright, so it is a square. Alright, so the perimeter is all sides added up. So I end up with 8.96 units. And so I'm told that 1 unit is 100 feet. So if I have 8.96 units, I'm going to multiply that by 100 because every 1 unit is 100 feet. That's going to give me 896 feet. So I would need 896 feet of fencing to enclose that park. So make sure you write down any questions. If there's any numbers or anything that I did that doesn't make sense to you, please make note of it so we can talk about it tomorrow. Alright, so example 2. Plans are being made to build Quad City Mall at 23, 21, 54, and 53. The construction team will need to lay a concrete slab for the mall. So how much total concrete will be needed to lay in order to cover the foundation? So if I'm covering something, it's going to be 2-dimensional. Like if I paint a wall, I'm covering the wall in paint. I'm not only going vertically, but I'm also going horizontally at the same time. So I'm covering that whole space. So here we are talking about area because it's asking me to cover that. A walkway needs to be placed around the outside of the mall. What will the length of the walkway be? So if I think about a walkway, it is only going around the edges. So this here, we're talking about the perimeter. So I need to find the area and the perimeter of this figure that's being graphed on the coordinate plane. So I don't have any graph paper, so I'm going to need to go get some. Alright, so here's my graph paper. I'm going to graph point 2, 3. I'm going to call it A because it's not named. 2, 1. I'm going to call that B. C is 5, 4. And then D is at 5, 3. So here is my figure. Alright, so I need to find the area and the perimeter. Okay, so the figure on the graph, obviously I can't use length times width or base times height or anything like that. So what I'm going to have to do is I'm going to have to use the subtraction method. So I'm going to enclose it into a rectangle that does have right angles. I'm going to find the area of that, and then I'm going to subtract out this piece right here and this piece right here because those are not part of the concrete slab that mall will be part of. So I'm going to find the total area. So the area of that rectangle is going to be 3 times 3, which is 9. But then I'm going to subtract out the two pieces that aren't parts of that. So I'm going to call this part 1 and this part 2. And I see that they are right triangles. So I can use base times height divided by 2. So the area of part 1 is going to be the base. So when I look here, that's 2. And the height is 3. Or you could do 3 times 2. It doesn't matter. So 2 times 3 divided by 2, which is 3. And then the area of part 2. So I know I'm subtracting out 3 units just from this piece. And then the area of part 2 is going to be 3 times 1 divided by 2, and I get 1.5. So what's being subtracted out is 4.5. So the 9 units that is this whole rectangle minus 4.5 units that make up the pieces that aren't part of that slab gives me an area of 4.5. So, and it is area, so it's units squared. So the total concrete will need to be 4.5 units of concrete. Alright, so then the next thing it's asking is about the walkway. So we said that's perimeter. So I need to find the length of each side. Well, there are two sides that are going to be nice and easy to find, and they are this side right here and this side right here because they're right on the grid. So I'm going to clean this up a little bit. Alright, so I'm going to find the length of AD is nice and easy. It's 2. And the length of BC is nice and easy. I can see it's 1. So now I need to find the length of AB, which is going to be the square root of 1 squared plus 3 squared. So 1 squared plus 3 squared gives me this length right here. So that's 3.16. And then DC is going to be the square root of 3 squared plus 2 squared. And that gives me 3.61. So 2 plus 1 plus 3.16 plus 3.61 is 9.77 units. And that's linear, so it's just units to the first power. So I would need 4.5 units squared of concrete and 9.77 units for the length of the walkway. So again, write down any questions that you have. So if there's any numbers or processes that I did that don't make sense to you, please make sure that you write it down. And we'll talk about it tomorrow. So just a reminder, the area of a parallelogram is base times height. We're also going to talk about factoring, which is an Algebra 1 skill. that's essential for geometry and on into Algebra 2 and beyond. So I'm going to do a few examples of factoring in this lesson. If you need more examples, then I'm going to give you some extra practice with that. Another thing, if you're given the area of a parallelogram, this is just what we talked about. So if I was told this is the area, I need to factor it to find the dimensions of the sides. And then we're going to talk about using the T-chart is the method we're actually going to use, not the box method. All right, so if I think about area, I know that I'm talking about base times height, and that gives me the area that's inside. So if I wanted to find the length of the base or the length of the height, I need to look for the two numbers that are multiplied together if I'm given the area. So that's kind of the idea that we are dealing with right here in the area of a rectangle. So this is the total area, and I want to figure out what two numbers got multiplied together to give me that area. So I'm essentially factoring. You may have heard this as bust the B. That's how we dealt with it last semester, those of you who had me for algebra. So the first thing I need to do is I need to find A, B, and C. So A is always the number with the x squared term, so that's 1. B is always the number that is with the x term. And then C is my constant, or the number that is with without the variable, so 12. All right? So the sentence that I want you to memorize when you're factoring is we're looking for the factors of A times C that add or subtract to be B. So that's the sentence. The factors of A times C that add or subtract to be B. So the pieces that go in there in this particular problem is what are the factors of A times C? Well, A times C is 12 because 1 times 2 is 12. I'm sorry, 1 times 12 is 12. So I'm looking for the factors of 12 that, and to determine whether I add or subtract, I'm going to look at the sign that's in front of my C term. So in this case, there's a plus sign. So I'm looking for the factors of 12 that add to B, and then we just put in our B term. So in this case, our B term is 7. So the factors of 12 that add to be 7. So when I think about that, I know that the factors of 12 are 1 times 12, 2 times 6, and 3 times 4. So when I think about the factors of 12 that add, 1 plus 12 is 13, so that won't work. 2 plus 6 is 8, so that won't work. But 3 times 4 is, 3 plus 4 is 7. So I found the factors of 12 that add to be 7, and they are 3 and 4. So my binomial, or my trinomial, is now going to be x and x, because what times what is x squared? Well, that's x times x. And then I've broken it up into 3 and 4, because 3 times 4 is 12. But also, a positive 3 and a positive 4 are going to give me that 7 of the 7x in the middle. So if I were to multiply this out, so x times x is x squared, x times 4 is 4x, 3 times x is 3x, and then 3 times 4 is 12, and then combine my like terms, so I multiplied it out, and I got this, and then I combined my like terms, I ended up with the original problem. So 3x plus 3 times x plus 4 gives me that area. So that would make the base x plus 3 and the height x plus 4. Now, since I'm multiplying, those could be switched. This could be x plus 4 and this could be x plus 3. But those are the dimensions of the figure. This is an x plus 3 by x plus 4 rectangle. All right, so number 4, the area of a rectangle is, okay, I see that I have that expression. So I know I'm going to factor this. I want to know the dimensions of the rectangle. So I'm looking for what two numbers got multiplied together. So I'm going to use that sentence. So I'm going to write that sentence out. So I'm looking for the factors of A times C. So let's go ahead and let's write out what A is, what B is, and what C is. so A is the number in front of the k squared, or the squared term, so it's 1. B is negative 13, and C is 40. So I just pick those straight out, and I keep the sign that's in front of them. So minus 13 is negative 13, and 40. So I'm looking for the factors of A times C. So I'm looking for the factors of 40, because 1 times 40 is 40. That, and I need to decide if it's add or subtract. So I always go to this right here, and that's a plus sign. So I'm looking for the factors of 40 that add to B, and I want them to add to be B, so negative 13. So the factors of A times C that add to be B, and B in this case is negative 13. So when I think about the factors of 40 that add to be negative 13, I'm going to just go through those different factors. So when I think about multiplying two numbers together and the answer is positive, they can either both be positive or they can both be negative. So the ways that I can get 40 are 1 times 40 or negative 1 times 40, negative 40, 2 times 20 or negative 2 times negative 20, 4 times 10 or negative 4 times negative 10, and 5 times 8 or negative 5 times negative 8. So when it's positive, I need to think about all of the positive and negative ways. And so if I notice in this one, my B is a negative 13. So if I add two positive numbers together, like 1 plus 40, I'm going to get a positive answer. 2 plus 20 is positive 22, 4 plus 10 is positive 14, and 5 plus 8 is positive 13. So I'm going to rule out all of the positive versions because I know my answer has to be negative. So if I notice when I did 5 plus 8, I got positive 13. So negative 5 plus negative 8 is going to give me that negative 13 that I'm looking for. So the factors of 40 that add to be negative 13 are negative 5 and negative 8. So the dimensions of my rectangle are going to be k minus 5 and k minus 8. And that's my answer. So go ahead and pause the video, and I'd like you to try number 5 on your own. Alright, so hopefully you found that the dimensions of the square, which a square tells me that all the sides are equal, and if you notice, I ended up with b plus 8 times b plus 8. You may also see this written as b plus 8 squared, because there's two of them. So that's another way you could have written the answer in a simplified version. So if you got that, you can go ahead and move on to the next problem. If you didn't, then I'm going to walk through the process here. Alright, so I was looking for the factors of A times C, which is 64, that add to be 16. And so I noticed that 16 is positive. So remember we talked about I can either have a positive times a positive, which gives me that positive 64, or I can have a negative times a negative, which will also give me that positive 64. But when I'm looking at what I want it to add to, I want it to add to be a positive number. Well, a negative number plus a negative number will never give me a positive. So I could have, just like up here, I could have written out all those factors with 1 and 64 and then negative 1 and negative 64, 2 and 32, negative 2 and negative 32, and done that like I did up here. But I just used my common sense and realized I wanted all the positive versions. So when I wrote out the factors, I ended up with 8 plus 8 is 16, and 8 times 8 is 64. So this became b plus 8 and b plus 8. So I know that these factoring ones can be a little bit confusing, so please make sure you look over example 3, 4, and 5 and see if any of the things don't make sense to you, and go ahead and circle those or make note of those or write any questions that you have, and we'll talk about it tomorrow. Alright, the last thing we're going to talk about is just here's some reminders. Parallelograms, these are the characteristics. Opposite sides are parallel. Opposite sides are also congruent. Opposite angles are congruent. Consecutive angles are supplementary. Or one set of opposite sides are parallel and congruent. Those are ways that I can prove something is a parallelogram. Rectangles, we have all of these characteristics plus 4 right angles and congruent diagonals. A rhombus is all of these characteristics go to the rectangle, they also go to the rhombus, plus 4 congruent sides and the diagonals are perpendicular. And then the square is all of those parallelogram characteristics plus the rectangle characteristics and the rhombus characteristics. Okay, so just a kind of refresher of what those different shapes include. All right, so for number 6, example 6, Ryan uses the following information to make the claim that quadrilateral ABCD is a rectangle. So remember, there's those characteristics of a rectangle that we need to have. So let's go ahead and let's look at the different information that they give us. And I'm going to go ahead and draw the figure because I'm very visual, so I need to see this. So A, B, C, and D. All right, he says it's a rectangle, so I drew it like a rectangle, but let's see what information we have. So the slope of AB is equal to the slope of CD. So we're talking about AB and CD. And what do I know if slopes are equal? That means that those sides are parallel, because if they have the same slope, then they're parallel. So I'm going to go ahead and say that those two lines are parallel. I know that the slope of AD and the slope of BC are also equal, so I can conclude that those are also parallel. So far I do have two opposite sides that are that are parallel. And I know that AB is congruent to CD. So AB is congruent to CD. And I know that AD is congruent to BC. But I know that they're not congruent to each other. Just those opposite sides are congruent. All right, so the information given is that opposite sides are parallel and opposite sides are congruent. And do I have enough information to say it's a rectangle? Do you agree or disagree, and why? Go ahead and pause the video and see if you agree or disagree. So I originally agreed because the opposite sides are congruent and the opposite sides are parallel, but then I remembered that the only difference, one of the differences between a parallelogram and a rectangle is that a rectangle is a parallelogram with right angles. So both a rectangle and a parallelogram have opposite sides congruent and opposite sides parallel, but I don't have any information making that right angles to make it a rectangle. So that's why I disagreed. So my justification is there's not enough information given to classify it as a rectangle. I would need to know either that there are right angles or that those diagonals are congruent, because when the diagonals are congruent, those right angles are the reason that the diagonals are congruent. So I do not have enough information, and be very, very careful when you're on your assessment that if you see things that look like it might be the shape that they're given, you have to have that extra information that isn't just a parallelogram, but that's also specific to the shape that you're trying to prove. All right, make sure that you write down any questions that you have or any places of confusion, and we will talk about it tomorrow. All right, so in number 7, I need to solve for x in the parallelogram below. So I am told that this is a parallelogram. So because I'm told it's a parallelogram, I can assume all the things that are true about a parallelogram. And I realize that I'm dealing with the angles when I look at this. So I've got my parallelogram here, and then somebody has dropped down a right angle. This right here is a right angle. So I need to solve for x, which x would be this little angle right here. It's not this whole angle, but just this little piece of it. So what do I know about the angles of a parallelogram? Well, I know that opposite angles are congruent. I also know that consecutive angles are going to be supplementary. So I'm actually going to use that second piece of information. Knowing that this is 131, I know that this angle and this angle are going to be supplementary to 131. So if I know that 131 and this angle right here are supplementary, to find this angle, I can just do 180 minus 131, and I get 49 degrees. So I know that this angle right here is 49. I'm looking for x, and what I notice is that I have this triangle right here. And since I know this is a straight line and this is 90, that means this also has to be 90. So that green triangle, I can use the triangle sum theorem to find the measure. So I can say that 90 plus 49 plus x equals 180, and now I just solve for x. And I get x is 41 degrees. All right, go ahead and pause the video. I do want to point out that I see this is a trapezoid, and I see that these two legs are congruent. So I can actually say this is an isosceles trapezoid. So go ahead and pause the video and see if you can use the characteristics of an isosceles trapezoid to solve for measure of angle 1. So what's the measure of this angle right here? All right, so I ended up with the measure of angle 1 is 44 degrees. So let's go ahead and figure out how we got that. If you got that, you can go ahead and finish off your notes. I would like you to go through and make sure you write down any questions that you have or specific problems that you want to talk about. And then I'd like you to make a summary. So just like a remember to things that you were confused about, things that you need to remember when you go to study for your test. All right, I'll go over this now. So because it's an isosceles trapezoid, just like an isosceles triangle has two congruent sides, and the angles that are opposite of those sides are also going to be congruent. So if this is 46 degrees, because this is an isosceles trapezoid, this will also be 46 degrees. And this right angle right here makes a small right triangle. So 90 plus 46 plus the measure of angle 1 equals 180. So then I did 90 plus 46 and got 136, plus the measure of angle 1 equals 180. And then I solved for the measure of angle 1, and when I subtracted that 136 from both sides, I got 44 degrees. And as you look over these last two examples, make sure that you write down any questions that you have or any places that you were confused, and we will talk about it tomorrow.